Okay, let's proceed with this one. These are reactions of alkene. This is on page 34. Now, the type of reactions that alkenes undergo, these reactions are called electrophilic addition. Okay, so all of their reactions are called electrophilic addition. Now, the word philic, if you remember, it's like hydrophilic, right? So hydrophilic, or like I just told you, nucleophilic. Philic means love. It's kind of, it means love. Okay, so electro is electrons. Okay, so it is love for electrons. Okay, so it's an addition due to love for electrons. Okay, so that's basically what it means. Okay, so if you look at an alkene, alkenes have double bonds, right? It has double bonds. So this area is considered to be an electron rich area where the double bond is. This is an electron rich area. So anybody who is attracted to electrons will love to come to this area. Okay, so that's why we call it an electrophilic addition. Okay, so some of the examples of electrophilic additions that you may have seen from even high school is, like, for example, halogenations. Okay, this is basically where you add things like bromine, or you add things like chlorine, or you add things like iodine, okay, to alkenes. So for example, let's say we take propene. Okay, let's say we take propene. I'm going to use propene as an example. So we take propene and we do addition with bromine. So if you remember, bromine is, what am I saying? Bromine is, let's say, a reddish brown, okay, color. So when you add it with an alkene, it undergoes decolorization. Okay, so this is a test which is normally done for unsaturatedness. If you want to know if something is unsaturated, you add bromine, and then when you add bromine, the color becomes decolorized. That means reddish brown become colorless. So this is a test that we do for alkenes, or somebody who has double bonds. All right, so bromine adds on both sides. So this reaction is done at room temperature and pressure. That means room temperature and pressure. Room temperature and pressure, RTP would be, like, for example, 25 degrees Celsius and 1 atmosphere. Okay, that means you can just do it at room temperature. No need to heat up, no need to do anything. Okay, so that would be RTP. So this reaction I just told you is the one which is used for testing. So what you will observe is reddish brown, brown becomes colorless. Okay, so this is a test for unsaturated ratedness. Okay, unsaturatedness, to test for if something has double bonds in them. All right, then the other thing that we normally will do is, like, for example, we can add hydrogen halides. Okay, hydrogen halides. Now, hydrogen halides are, like, for example, HCl or HBr or HI. Okay, so let's take the same guy again. Let's take propene. All right, so we add, let's say, HBr this time. So when we do this, right, you can get two possible products. Okay, see, you get one like this, and let's say another one like this. So in the first case, you can get the hydrogen here, and you can get the bromine over here, or you can get the bromine over here and you can get a hydrogen over here. So these are the two possibilities that you may have. Okay, these are the two possibilities that you can get. So just to let you know, usually this will be the major product. Major, this is the major product, and this will be the minor product. Okay, major and minor, because usually what happens is the hydrogen will prefer to be attached to a carbon that already has more hydrogens than the other carbon. You see, like in this carbon, right? This carbon already has 2 hydrogens here, so it will prefer to add to this carbon. Meanwhile, here in this carbon there is only 1 hydrogen. So hydrogen always prefers to add to a carbon that already has a lot of hydrogens, right? So that's major product. So that's hydrogen halides. And then the other reaction that you may know is hydrogenation. Okay, hydrogenation. Now hydrogenation is basically adding hydrogen. All right, sorry, come back here again. This reaction is also done at room temperature and pressure. Okay, hydrogenation is adding hydrogen. Now this reaction is basically converting double bond into single bond. Okay, so this reaction is done to convert usually vegetable oils into solids. Okay, like for example margarine or butter. Okay, margarine or butter. So in this reaction what happens is you take an alkene. Let's say again we take propene. We add hydrogen. Okay, this reaction is done at high temperature and pressure. Usually it's done at 180 degrees Celsius, and you need a catalyst. The catalyst can be platinum, okay, platinum or nickel. Okay, you add platinum or nickel, and then what happens is you get hydrogen being added over here. So the double bond breaks up. Okay, so the double bond breaks up and you end up adding hydrogen there. So this is called saturatedness. Okay, to convert something from having double bond into something which is saturated. Now then the other reaction is, how many are we? Okay, we are at number 4. The other reaction would be hydration. Okay, hydration basically is adding water. Okay, adding water. So this reaction is basically what you are going to do is you're going to take again your alkene. I'm going to use propene again, and you add water. Ta-da! You add water. All right, and water usually, okay, no man, let's forget the state first. What happens here is you add water. Okay, again you get two cases. First case is hydrogen adds over here and the OH adds over here. Second case is OH adds over here and the hydrogen adds over here. All right, and if you remember what I told you just now, hydrogen will always add to the carbon that already has more hydrogens, right? So this will be the major product, and this will be the minor product. Okay, minor product. So hydrogen always adds to the carbon that already has more. So in this example here, what you end up getting is you end up getting propan 2-ol and propan 1-ol. Okay, propan 2-ol and propan 1-ol. So you get propan 2-ol, and this is propan 1-ol. Okay, that's the other reaction that you can go through. Now this reaction, right, this hydration reaction, there are two possible scenarios. One is you use sulfuric acid. Aqueous has a catalyst. This is a catalyst. Okay, at room temperature and pressure. That's one. That's what you can do in the school lab, small scale. This is small scale example school lab. Okay, but on an industrial scale where you're going to end up producing a lot of alcohol, okay, a lot of alcohol, what you do is you use phosphoric acid as a catalyst. Okay, you use phosphoric acid as a catalyst. You use a pressure of 60 atmospheres and a temperature of 300 degrees Celsius. Okay, 300 degrees Celsius, that's what you're going to do. All right, so that would be in industry. Okay, industry. So this is industry. Okay, industry. All right. Then I think one more reaction would be what number are we at? Okay, we're at number 5 now. The other reaction would be polymerization. Now polymerization is basically, it undergoes what is called as addition polymerization. Okay, addition polymerization. So what happens is you take let's say propene, right? So what we're going to do is, remember I drew propene for you like this, isn't it? Okay, this is what I did. So what we're going to do is we're going to rearrange this so that it looks like this. So we focus on the double bond. All right. And then what we do is we take this guy and then we stick him up or down. Now we push this up or down. So for example, this becomes like this. Let's say CH3. Okay, CH3. And then this is the H. Okay, so we make it look like this. Okay, so we push this down. Oh, sorry, what did I do? We push this up here, and then slight change in plans. Okay, so imagine this was here, right? Okay, let's say imagine this was here. So that's what I just did. I just pushed this up. All right, so this is up. So I make it look like this. And then when I do addition polymerization, what I do is I just keep repeating this unit over and over again. Maybe I don't put a double bond here. I remove the double bond. Okay, wait, let's leave the double bond. Okay, so CH3, okay, and then another one here, another CH3, another one here, another CH3, okay, and then I just put all those hydrogens there. And then what I do is I remove the double bond. Okay, so now we have single bonds, right? So we remove the double bond, we have single bonds, and then the other bond that we broke, we just connect them together. Ta-da! Okay, so we're done now. So that's how it will look like. Okay, so then it just continues like that. So that would be addition. So this will be called polypropene. Okay, polypropene. Okay, so this would be called polypropene. So what the target here would be to make it look like this. All right, so that the double bond is exposed and everything else is either sticking upwards or sticking downwards. All right, for example, okay, let's say you had like this. Okay, so let's say you have something like this. This would be called what? This would be called but 1 in. Okay, but 1. So we want to make this look like this, right? Like this. So what we're going to do is we're just going to focus on this part. All right, we're going to focus on this part here. So what we're going to do is we're going to put the double bond there. All right, we leave that hydrogen sticking up there like that. We put this down like this, and then what we're going to do is we're going to take this group. And we push it down. All right, we push it down. So we push it down, and then it is actually CH2 CH3, right? CH2 CH3 is what? C2H5, right? So this group is C2H5. Okay, so that's what we're going to do. So we draw it like that. Then later on, when you want to do addition, what you can do is you can just remove this line here. Okay, remove this line here, and then you just draw one line out, bracket, and you just put an N. Ta-da, done. This is a symbol to show polymerization. Okay, this is a symbol to show polymerization. So the complete equation will look something like this. Like for example, you just put an N here, and then you put arrow, and then that's it. That's how it looks like. Okay, so that is how we represent addition polymerizations. Okay. Okay, so I think that kind of concludes the alkene reactions. Okay, concludes all the alkene reactions. Okay.